Google has just released VaultGemma. What makes this release so special is that it's the first open source AI model of its kind that has been fully trained with differential privacy. Don't worry if that term sounds complicated. It basically means this model is designed in a way that keeps the training data safe and private, so it cannot accidentally leak personal information about anyone. Now in this video, I'm going to break down everything you need to know about VaultGemma. To understand VaultGemma, we first need to know where it comes from. Google has been building a family of AI models called Gemma. These are what we call open weight large language models. In simple words, that means Google doesn't just keep the model to itself, they actually share the model's weight, so developers and researchers around the world can use, study, and build on top of it. Gemma was designed to be more transparent and accessible compared to the closed AI models that big companies usually keep behind locked doors. Now here is the big issue. In the past, many AI models have been criticized because they sometimes memorize information from their training data. For example, if an AI was trained on a piece of text that contained private or sensitive details, there was a risk that it could later spit that information out when prompted. That's obviously a huge privacy concern, right? Imagine if an AI accidentally revealed someone's phone number, email, or other personal details. Not good at all, right? On top of that, governments and regulators around the world have been putting pressure on AI companies to do better when it comes to privacy and safety. Laws like GDPR in Europe and the AI Act are setting strict rules, and companies like Google need to show that they are building AI responsibly. This is where VaultGemma comes in. Google built this model from the ground up with privacy as the main goal. Instead of just making a powerful AI, then trying to patch in privacy later, they trained VaultGemma in a way that makes privacy part of its foundation. You could say this is Google's big answer to the question, can we build AI that's both useful and safe for people's data? Now let's get into some of the technical details of VaultGemma. But don't worry, I will keep it easy to understand. First, the size of the model. VaultGemma has about 1 billion parameters. 1 billion is a lot, though compared to giant models with hundreds of billions or even trillions of parameters, this is considered mid-sized. Next, we have the context length, which is 1024 tokens. Context length is how much text the model can see at once while trying to understand or respond. So VaultGemma can look at about 1000 tokens at a time, which is a decent length for most everyday tasks like answering questions or writing paragraphs. In terms of architecture, VaultGemma is built on something called a transformer, which is the same technology behind most modern AI models, including Google's earlier Gemma models. You can think of a transformer as the blueprint that tells the AI how to process language step by step. For the training, Google used TPU v6a chips, which are specialized supercomputers built specifically for AI. They are designed to handle massive amounts of calculations quickly and efficiently. Now here is the important part, the training method. VaultGemma was trained with something called DPSGD, which stands for Differentially Private Stochastic Gradient Descent. That's a mouthful, but in simple words, it means that during training, the AI doesn't just take the raw data directly. Instead, it uses 3 tricks. The first trick is called clipping. Imagine if one piece of training data was really strong and tried to pull the model too much in one direction. Clipping makes sure that no single example has too much influence. It's like setting a limit so every piece of data, no matter how unusual, only has a small, controlled impact on the model. The second trick is called noise. Here the idea is to add a little bit of randomness into the training process. You can think of it like slightly blurring a picture. You can still recognize the overall shapes and patterns, but you cannot clearly see the fine details. By adding noise, the model learns the big patterns of language without holding on to the exact personal details. And finally, there is subsampling. Instead of training on the entire dataset all at once, the system only looks at random silences of the data during each training step. This makes it even harder for the model to memorize specific examples because it never sees all the information in one go. Over time, it still learns the overall patterns of language, but in a way that keeps individual data points hidden in the crowd. Together, these 3 techniques, clipping, noise, and subsampling, are what give VaultGemma its strong privacy guarantees, making it very unlikely that the model will ever leak sensitive information. Now let's talk about how VaultGemma actually performs. I want to be upfront here because this model was trained with privacy as the top priority. Its accuracy is lower than regular non-private AI model of a similar size. This is the trade-off. You get stronger privacy, but you give up some raw performance. Let's look at a few numbers so you can get the picture. On a benchmark called PIQA, which tests how well the model can reason about everyday situations, VaultGemma scored about 68. On BullQ, which checks if the model can answer yes or no questions correctly, it scored around 62. On a more challenging test called ERCC, which is like a tricky multiple choice science questions, it got about 26 when tested with 25 examples. So yes, in terms of raw power, VaultGemma isn't breaking records. But here is the really important part, and this is what makes VaultGemma stand out. In what's called memorization test, researchers gave the model a piece of text that was part of its training data and checked if it would repeat that exact words back. And the result? VaultGemma did not repeat or leak any private details. This means it learned the overall patterns of language, but it did not store or memorize the personal information that was in the training data. So while it may not be a strongest model for pure accuracy, it's a huge win for privacy and safety. Of course, like every technology, VaultGemma also comes with its own set of limitations. The first and most obvious one is accuracy. Because of the way it was trained with differential privacy, it doesn't perform as well as standard, non-private models of a similar size. In other words, while other models might give sharper or more precise answers, VaultGemma sometimes falls behind because privacy has been prioritized over raw performance. Another limitation is that it requires more computing power during training. The privacy techniques like adding noise and clipping gradients make the training process heavier and more resource intensive. This means it costs more time and hardware to build a model like this compared to a regular one. Also at this stage, VaultGemma is only trained in English. That means if you try using it for other languages, the results may not be reliable. For people working in multilingual environments, this limits its usefulness right now. And finally, it's important to remember that privacy does not automatically solve other big AI challenges like bias or misinformation. VaultGemma may protect individual data, but it can still produce biased answers if those patterns existed in the training data. It can also make mistakes or generate incorrect information, just like any other language model. While VaultGemma is a big step forward for privacy, it's not a perfect solution to all the challenges we face in AI today. If you are wondering how you can actually try out VaultGemma, the good news is that it's already available on the public. Google has released the model on Hugging Face, which is a popular platform where AI models are shared. There you can find the model weights, basically the trained brain of the AI, along with the model card, which is a detailed guide explaining how the model works, what it was trained on, and what you should or shouldn't use it for. Google has also published a full technical report on the Google Research blog where they go into all the details about how VaultGemma was trained, the privacy guarantees, and the test they ran to prove it doesn't memorize personal data. And finally, VaultGemma is officially part of Google's Gemma open model lineup. Now, I would love to hear what you think. Do you believe privacy should be the top priority in AI, even if it means giving up some accuracy and performance? Let me know your thoughts in the comments. I'm really curious about your perspective. And if you found this video helpful, don't forget to give it a like, share it with others who might be interested in AI updates, and subscribe to the channel for more videos like this. Your support means a lot and helps me keep bringing you these breakdowns.